Hi everyone, I'm going to be going over question number 61 from the Chapter 7 Bingo Problems. This question is wondering, it says, what is the u function u of x for force? And then it says, let u of x go to 0 as x approaches infinity. And then it gives the magnitude of that force function, which is alpha over quantity x plus x naught squared. It also gives, it says sigma, or alpha, equals 800 newton meters squared, and x naught equals 0.2 meters. So we'll get going on the u of x function. So the way we do that is we need to take this f of x function, and we know that, or actually, before we take this, so we know that f equals negative du over dx. And if we rearrange this, we can get du equals negative f dx. And so to get u alone, what we will need to do is integrate this. So we'll set up an integral. So we'll end up getting u equals, and we'll pull out the negative, so negative f dx. So now we have our integral set up. Now if we remember, here is our f function. And so we'll substitute that in for the f here. So we'll get u equals negative, and then alpha over x plus x naught squared dx. So now we have that, and we know that we need to integrate this, just given these parameters. So we have x infinity. So now that we have our integral set up, we need to integrate it. So as we do that, we'll end up with negative alpha and then u equals, these cancel, so we end up with u equals alpha over x plus x naught. So now that we know, and I guess that is u of x, not just u, so u of x. So now that we know u of x, or u, either way, it's u. So that's part A. But now part B wants to know, it says object with mass 0.5 kilograms released from rest at x equals 0 and moves in the plus x direction. What is the object's speed when x equals 0.4 meters? And so I'll erase this, and we'll do part B. So okay, so since we're dealing with the this movement and everything, let's use energy equations. So since we're starting, it says it's released from rest, so we know it's starting at nothing, like no velocity, so the kinetic energy at first is going to be 0, but it will have potential energy. So we'll say u1 equals and then at the end we'll have kinetic energy and potential energy. So now that we have that, we can plug in the values we know. So we know that we can plug in for both of our u's, we can plug in our u of x that we found in the last step. So sigma over x 1 plus x naught equals, and then K2 we know equals 1/2 mv squared plus alpha over x 2 plus x naught. So now that we've expanded this sum, now we can take the values that we already know and plug it in, and we are going to want to solve for the velocity. And so sit down, we end up getting, so we know that alpha is 0.8 over, and x1 is equal to 0, x naught, we're given 0.2, and then that equals 1/2. Mass is 0.5 kilograms times v squared, which we don't know, plus the 0.8 over x2 is 0.4. Rewrite that, that looks kind of bad. So 0.4 plus 0.2. And then all we need to do is isolate v squared. And so we'll subtract this over and then divide everything by this to get v squared. And that ends up being v squared equals 10.67. We take the square root, and v equals 3.27 meters per second. So that means that this object that has a mass of 1/2 kilogram, as it's released from rest at x equals 0, when it hits x equals 0.4, it is going 3.27. So basically 3 and almost 1/3 meters per second. So thanks for watching, and I'll see you in the next video.